Okay, well, I think we'll start. Welcome everybody to hear about Ian's net zero studio flat. I'm really looking forward to this because I think he's got some really interesting and skillful ideas. So, as usual, if you can everybody other than Ian can remain muted except when called on to speak. That's really helpful to help cut down the background noise. We will be taking questions at intervals, and Libby will be collating those. So if you have a question, do put it into the Zoom chat. Then Libby can see who wants to ask what. We are recording this session, so and then we'll be putting it on the Open Ecombs website, CCF website. So if you don't want to feature in that, please put it in chat, and then Tom will make sure that you get edited out when it actually goes online. So I think that's the main things. I will unshare this, stop that sharing that, and it's over to Ian.
So good evening. Yes, we have this small barn next to our house in Millway, Grantchester, which we bought the whole site, the house and rubbishy buildings, in 1985, and the original house was built in 1800. It was it arose because the fields of Grantchester were enclosed in 1800, and there was a market garden which was formed here, and this house was built to service the market garden. We bought it in 1985. The house was derelict. There was no barn where I'm sitting at the moment. So we refurbished the house, and then we built a building for my architect's practice next door, which is across a courtyard, across a car park, just opposite, in 1990. And then in 1995, we built this building. I had a summer off, and a friend and I self-built it over a summer, and we had fun. Can you show the site plan, please?
Okay. Right, now hopefully that's the site plan. Yeah, good. Okay,
good. Right, the house is bottom right. The office which I built is in the middle of the screen. At the top, left is where your pointer is, and the barn is to the right of the screen. And there's a big tree overhanging it, and that is the barn. The south is left down the page, so solar panels on the office, which is in the center screen, face almost due south, and new solar panels, which we're going to fit relatively soon, on the roof of the barn, and on the roof of the barn will face south. On the house is more problematic where they face. Anyway, can we have the next external photograph, please?
Okay, so I think I need
Number 2.
Sorry, I just need to stop sharing that. Okay.
Anyway, this is a side view of the barn. It's a very conventional building. The window in the middle of the wall was a reclaimed building from a project which wasn't used. Can we go to the next photograph, please? There we are. Right. That shows the entrance door to the flat, and it shows the some of the projections which we added on the first floor to accommodate extra insulation. The original building had 150 mil of rock wool insulation, 100 mil between studs and 100 mil over the studs. We've added between 100 and 200 mil of polyurethane insulation to give extra insulation. And we rather like the idea that it's a bit cranky in that the surfaces step in and out to accommodate insulation, to accommodate rainwater pipe, provide shelter for the entrance door. Can we have the next slide, yes. This is a photograph taken a month or so ago, middle of project, showing the first floor. It's about 50 square meters of accommodation, and there's a mezzanine, which is the timber object you see halfway up the screen, which is going to provide a bed space. If we go to the first floor plan, which is the next one, this is a bit hazy, I'm afraid, because it's drawn in pencil. But you can see there are 4 columns which sort of frame the space in the middle of the space. And if you look on the right, you can see 2 of them going down to very deep foundations. There's a better drawing of this later, but the point here is that we have problems with shrinkable clay here, which is clay which, if you don't know it, is rock hard in summer and turns into jelly in winter. And tree roots love to dry it out and mess around with it. So you have to have very deep foundations. But there's a better section which shows you that in a moment. But there's a stair on the right of the plan, and I'm sitting along a desk, which is halfway along the top of that plan. There's going to be a kitchen, which is going in at the moment, which is bottom left, and there's a shower room and loo top left. And so it's a compact studio flat, and there's going to be a sofa bed downstairs and another bed upstairs. Excuse me. So there's a choice of where they sleep. Can we have the next? Yes, the next drawing, which is a section which shows a little bit more of what is going on.
All right. Sorry. Just in my head.
Slide 6.
Yeah. No, sorry. I just make sure I got it up. Right. Okay. Now share screen.
Yeah, that gives a better idea of where we are. The green on that drawing is the Rockwool insulation, which went in 1995. The red is the polyurethane Celotex type insulation, which is wrapped up around it. Bottom of the screen, you see some blue lines, and that is a catch pit well, which we built. We dropped some 6-foot diameter, 1.8 meter diameter manhole rings between the foundations, sealed it with concrete, and we've used it for catching rainwater and groundwater. At the moment, we only use it for watering the garden. We have a large garden, so we do need it, but we could use it as grey water. We're not getting around to that yet. The reason I went for Celotex was largely because we have a mouse problem on site. The mice really love the rock wall, and I'm sort of getting around to putting all sorts of meshes in to stop the mice getting into the rock wall. But so far, they're not desperately effective. But also because the planners are a bit picky about the height of the building, I wanted to keep the height as low as possible. So I used something which is high performance, like Celotex. I was reasonably relaxed about the fire problem, which, when you use polyurethanes, as we know, polyurethanes can be dangerous in fire because all the internal walls are lined with rock wool and plasterboard. So the chance of a fire getting into the Celotex is relatively remote. So that seemed okay. The original building had a vapor barrier around it, which is a polythene sheet which wraps around the inside of the building and stops moist air drafts going out into the insulation. One of the issues we've had to resolve is in making alterations is joining new work to old and sealing those joints. And for that, if you go to the next photograph, that shows some of the games we played. I'm going to make you a bit seasick by lifting my phone off, and I'm going to show you The easiest way is this. This is the uni tape. Is that showing on my?
You're not showing, your video's dropped out in.
My video's dropped.
Okay, now come back again. Now you're fine.
That's the tape we've used. Some of you may be familiar with it. Some of you probably aren't. It's a really, really sticky tape, which allows you to join polythene to polythene, or anything to anything, actually. Your fingers to anything as well, if you get your fingers on the glue. It's a very efficient tape. And if people want to talk about different tapes, there's another one as well, which I've been using, which I don't have with me. And that's opposed to the standard PVC tape, which you can buy, say, from Ridgeons or one of the builders merchants, which does stick, but tends not to stick for long. It can get unstuck.
I'm sharing the image of the taping.
Well, the image of the floor, the blue tape around there is joining any cracks and joints in the polythene vapor barrier that wraps the way around the building. And when it is quite tricky, because you have to go around each joist and each junction, and it's a slow job. And I'm sort of halfway through doing it through the whole building. And when it's all done, and done around the windows as well, then I will probably get the building pressure tested with a passive house pressure test, which, if I've done that sealing properly, it should pass. Anyway, fingers crossed. The building is heated with a heat pump, a Wiesmann heat pump. Can we have a photograph of the Wiesmann heat pump? Yeah, there we are. And that is sitting on a box which contains all the expansion tank, an expansion tank for it, and various other bits and pieces. It's the smallest heat pump I could get. It does about between 6 and 7 kilowatts. The heat load on the building should be around 1.5 kilowatts. The majority of the heating will go towards heating hot water. You need about 2 or 3 kilowatts for heating hot water for showers and washing up and things. So we should be okay, because if you do your maths, 1.5 kilowatts of heat coming off the heat pump, plus say 2 kilowatts of heating hot water from cold, gives you 3.5 kilowatts. A person sitting down like me, sitting in this room, is generating 100 watts. Cooking and showering should generate another few hundred watts. So, I mean, we're well in the 3 kilowatts or 3.5 kilowatts we need for hot water and heating, with a 6 kilowatt heat pump, plus the casual gains from lighting, people, cooking, etc. Also on this picture is at the top of the picture, you can see a vent, and that is the vent for the mechanical ventilation and heat recovery. Because the building is very well sealed, there's this mantra which comes from the, well, originally I heard it from the Building Research Station, which was build tight, ventilate right. And if you're going to seal a building well, you have to ventilate it. So opening windows aren't acceptable. So you have a mechanical ventilation with heat recovery system, which takes the air you don't want from the kitchen and shower room, takes it out through a heat exchanger, which then warms up air coming in. And so air comes into the building at a higher temperature than outside temperature. And these MVHRs, mechanical ventilation systems with heat recovery, can be 85–90% efficient, amazingly. We have one on a holiday home in Scotland which works really well, but that's a whole house one. This one is a smaller one because I had difficulty finding one which was the right size for this sort of building. There are quite a few whole house ones on the market. There are quite a few room ones on the market, but not very much in between. They were difficult to find. Can we have the picture of the MVHR? There it is. It's a very simple unit. It takes stale air at the top. It discharges fresh air out the bottom. It's not fully installed yet. There are two ducts at the top which go up and across into the shower room and take the air out of the shower room. This one is called a Blue Martin, and it's marketed by a firm, I think in Kirkcaldy, north of the Clyde, which is a firm called Paul, who sell it. Right. Can we just pause here for questions? Has anybody got any questions?
Okay. Libby, are there any questions on the chat? Okay. I might ask a first one. You mentioned the sort of fire risk of Celotex and stuff. Did you consider using phenolic?
No, I didn't. I think Celotex is more efficient than phenolic. That's all. I didn't look at it very closely, let's say. I'm aware of phenolic resins or phenolic foams as being a possibility. But no, the Celotex we've used is a low flame Celotex. But as you probably know, once even the low flame Celotexes catch fire, they do catch fire and they produce lots of horrible toxic smoke. So the exercise is not to let them catch fire. So you should encapsulate them with something which is non-flammable, and it's all encapsulated within plasterboard. And of course, a lot of rock wool, which acts as insulation. So I think I'm relatively confident that we're not going to get the Celotex burning.
It's certainly a very common solution.
Yes.
So does anybody have a question or a comment?
There's one question that's been answered about what does MVHR stand for, but that's answered now. But unless you want to say anything more about that.
No other questions?
Can I ask a question about your? Sorry, my camera's not.
Yes.
Can I ask about your heat pump? How did you size it for the building?
Well, the calculated heat load for the building is 1.5 kilowatts, with 21 degrees centigrade inside and -1 degree centigrade outside. That's the calculated heat load. And with the mechanical ventilation system with heat recovery, one can predict how much air that will be taking out of the building, warm air it'll be taking out of the building. And so one can do a calculation on the heat loss from the mechanical ventilation system. So you've got two things. You've got the conductive losses from the walls, which you can calculate through the thermal resistances. You've then got the ventilation losses, which you can calculate through the MVHR. If it's a properly passive house building, the amount of extra leakage should be very small. And that comes, and then you've got your hot water. You've got to heat up. Say you need to produce hot water for showering. And so I calculated you needed something like 3.5 kilowatts in your heat for your heat pump. The smallest heat pump I could get was one that produced between 6 and 7 kilowatts. And it's just, I would like to have got a smaller one, but I couldn't find one. And so there we are. It could have been possible not to use a heat pump at all and just use direct electric heating, just use direct panel heaters as being a solution to heating the building. But I thought it'd be interesting to see if I could make a heat pump work and I could learn about them. I think a small flat, one might just use direct electric heating and not be bothered with the complexity of the heat pump. But then you still got to heat your water and your electricity bills would be obviously higher, but the capital costs are much lower. Does that answer your question?
Yes.
Convoluted answer. It's the
Yeah.
smallest I could get.
Thank you.
Watch made me choose that size.
Can I just ask who you can get to work out your heat loading and do these calculations? Obviously, you know how to do it, but for someone that doesn't,
Me.
you.
I've been doing it. I've been doing it for years and years and years, because I was involved in doing building research when I graduated.
Yeah. Okay.
And I know how to do it.
Yeah.
And yes, who do you get to do? Yeah, I don't know is the answer. I suppose a really good heating engineer should know how to do it.
Thank you.
I think from my brother's experience, when you get a heat pump, or particularly if you want to get some of the renewable heat incentive grants and things, the heat pump supplier has to work out what your heat load is. But I'm told from his experience that the danger of that is that they decide to double the size of the heat pump that you need just in case, which not only makes it much more expensive and means you need to have even bigger radiators than you did before.
Yes.
It also means it makes the heat pump less efficient.
Yeah, one of the things I didn't mention is that because the heat pump only produces heat at about 45 to 50 degrees C for heating your radiators, and the normal radiator temperature is about 80 C, then radiators have to be double the size that you'd want normally. And in this case, on this particular project, I've done a lot of reuse and repurposing, which I'll get onto in a moment. But the radiators, both radiators came from projects where they, for one reason or another, weren't needed, and they've just sat. For one of them has sat for about 30 years, being unused, and a few cans of spray paint, and it's perfectly acceptable. And part of the problem at the moment is that the heat pump system is not working perfectly. Well, the heat pump's working, but it's not, for some reason, providing the temperature it should for the radiators, which is why the temperature in here is 16 degrees and not. I've set it for 22 at the moment in the hope that I can encourage it to perform. And I would like the heating engineer to have come on this Zoom, and then he could have seen that he's not being covered with glory at the moment because the system isn't working entirely properly. It will work. It just needs debugging.
I think that's quite common. I think one of the nice things about open eco-homes, one learns about the things which work really nicely and the things which turn out to be a bit more tricky than one first thought.
Well, the draft proofing is tricky, particularly on a conversion, on a refurbishment, because you have to be a bit of a passive house obsessive. I'm afraid.
And I mean, I don't know if you want to discuss, why you're doing it and the benefits of being.
Well, I was going to get onto that in a moment.
Okay, sorry.
I'll get onto that at the end. I've got a little bit of I'd like to say about the history of the building and why it is it is, and then I'll talk about the future and what I'm hoping to achieve with this project. Okay. So can I carry on? What I'd like is the cross section, which it's the slide. It was the photograph 5, which you have. Can we have that again?
Get my head around cross section. Oh, the one I've already shown.
Yes.
Okay. I'm sorry.
Because I think it probably illustrates the point a bit better.
Is that it?
No, not that one. Next one. Next one. No, keep going back. You have to go back. No, we missed it.
It's a PDF, isn't it?
Yes, it's PDF.
Okay, sorry, I shared the wrong thing. Sorry, Ian.
PDF. Yes. There it is. Yes, that's right. I think that gives the problem of the site. We had a very large tree which was against the shed, which we demolished. And for that reason, we put in ground beams, which are those concrete things immediately against the tree roots. But the actual building structure had to come from something more stable than those ground beams. And so they are 3 meters deep pads which go down, down, down. And it's in the middle of those which we put the concrete manhole rings to get the tank to hold the water. Because the main structure is basically in the center of the building, the rest of the structure is quite light. We went to these telegraph poles, which, if I move my screen, my phone round, you can see, is that, can you change that?
Or are you? Okay, no. Okay.
Is that, I can't look at two things at once.
Yeah, no, I think that's got it. So yeah, there you are. So the grey vertical right hand side of the screen
are telegraph poles.
Yes.
And they support horizontal telegraph poles, both in the floor below my feet and also above my head. And I really like the idea of having 4 really chunky poles, which sort of define the space. And the mezzanine is slung between the horizontal poles, which go between them. The kitchen you can just see over there is going in. I've got a joiner starting on Monday to begin to help me fit that. Social distancing has been a problem. Let me put that back. Social distancing has been a big problem because I had various people working for me who I felt working with me, who I felt I couldn't work with because I just worried about catching something or giving them something. And so it has slowed down over the summer. The desk I'm sitting at is repurposed from the office, which was here before. I'm leaving that as it is. I think probably I'll finish by summarizing, or finish what I have to say by summarizing that, I built the office, which is across the car park, in 1990, and that's got a underfloor heating system and a ground source heat pump and extensive solar panels. It's got 4 kilowatts of solar panels on the roof. They, slightly embarrassingly, only provide half the energy the office needs. And I'd really like to work on that to try and make the office more efficient. I then, in 2003-04, built a super insulated holiday home in Scotland, in Galloway. A bit of Scotland, which is south of Carlisle, amazingly. And that has a mechanical ventilation with heat recovery system, whole house one. And substantially it's heated by burning driftwood and willows. We coppiced willows. We planted willows behind it, and we coppiced those to provide energy. We've now built this flat, and I'm hoping by finishing that I can learn how to do passive houses properly. And in the future, I'd like to make the Georgian house, which we live in across the drive, energy efficient. And there are various ways of doing that, which I'd like to learn from other people to find out how they've done it. And I'd like to enter into a discussion with people who are doing similar things to see what, to get the benefit of what they've done, and hopefully maybe give them the benefit of my experience and mistakes, because I think I see it as a learning process and something that's rather exciting. So if anybody wants to enter into a discussion on it, I'd be very happy.
Okay. So does anybody have any thoughts to share? And if we now have a sort of discussion bit. I mean, we live in terms of thinking about what we could do with the Georgian house. I mean, we're pretty obsessive about trying to minimize the air leakage in our Victorian house. Well, I suppose it's what is it? It's 1902, I think. and just a sort of lot of going around with a sealant gun around the skirting boards and trying to seal the drafts underneath the floorboards. And we've got a whole, in theory, we've got a whole load of triple glazed sash windows coming, or other fake sash windows coming. In theory, within a fortnight. I expect they probably were going to be late because the Green Building Store have been spectacularly not replying to our emails asking when they're about to arrive, which we suspect means somebody else has bumped us in the queue.
Yeah. The tapes, by the way, come from the Green Building Store, so they're very useful.
Yes, we used those when we were sealing underneath the boards of our hall floor. Yeah. And Bruce Hewitt's got a question asking what you use the building for.
Well, that's going to be let as a flat, and the idea is that it's going to be let so that it creates an income, and that income, I hope, will help pay for further building work, further energy efficient building work. Also, what I'm hoping is that I will be able to get lots of data from putting thermal probes into the depths of the insulation, monitoring how the heat pump works, the amount of energy it consumes versus the amount of energy it's producing, monitoring how the mechanical ventilation works, monitoring all those sorts of things and seeing if I can learn from them. And then I'd like to write them up so that people can benefit from that experience. I mean, there's a lot of research being done, but none of it seems to be very accessible, I find. So that is something I'm hoping to address.
Yes, I think there's definitely a need for the retrofit guide book.
Yes.
Because some of it's obvious and simple, and some of it's surprisingly complicated. I was just wondering, Ian, when we were doing a practice run, you did a bit of showing us around with your camera. There's a sort of little video.
Do that.
Shall we give that a go?
Yeah, I can do that. What I will do is, I was thinking, can I reverse it? Oh, yes, I can. If I reverse that.
That's good. That's done it.
Yeah. Then, so what I can do is the stairs up from the ground floor are like that. Nothing's particularly straight in this building, so the stairs are actually curved. The treads are, well, they're not quite railway sleepers, but they're almost railway sleepers. This is the main space, and this is one of the oversized radiators. Steep steps to the mezzanine, another oversized radiator, and all the kitchen units about to go in. Oh yes, I forgot to mention that I have a fan which is going to go over the hob and cooker, which doesn't throw the air away to outside. It recirculates it. It takes the air through a grease filter and a carbon filter. It's very similar to one we've got on the holiday home in Scotland, and that seems to work very well. But it's an energy efficient way of getting rid of smells in your kitchen. The loo in the shower is not finished. It's a bit of a building site. Does that help?
Just a question, Ian, on the recirculating fan. What do you do about steam?
Apparently, if I get back on, apparently the Blue Martin MVHR is sensitive to humidity. And if there's a lot of steam in the space, it cranks up the ventilation. So theoretically, the mechanical ventilation system should get rid of the steam. There is also a condensation drain on the MVHR, which should get any of that a lot of that steam will condense out if the system's working properly. The one we have in Scotland does very, very occasionally, if we're there over New Year, does condense.
Ian, someone's just asking to have another look at the radiator, please.
Certainly.
There, is that working?
Hang on. Let me just see if I can get it
Just
to do
sat
it again.
down, but I
There we
thought
are.
we'd move further on.
Radiator. That's this. It's a fin tubed radiator. It's quite big. I'm not sure who this one who manufactured that one. The one in the corner over there is made by a firm called Runtelrad. I'm not even sure they're still in business. That's a Runtelrad.
Claire, do you want to speak and talk to Ian about it? You've got a few questions about it.
Okay. Sorry, I'm doing my cooking, so so sorry you can hear onions probably. It's just yesterday on the air source heat pump, he was talking about the radiators having to be thicker. So I just wondered how thick. So I could see one of your radiators. Is it really tall?
Yes.
How tall is it?
5 feet. So it's 1.5 meters. Sorry.
Okay, and that's fine.
Don't stand beside it, Ian. Oh.
And how wide is it?
That's good.
Yeah, we can see it.
You can see, yeah, if I stand beside it here.
So it's on your right.
Yes.
Okay, that's it. Okay, thank you. And the other ones are more sort of standard size.
The other ones are more standard, but they're very thick. It's a very thick one.
And you said they're ones you've had for 30 years. Are they?
That one we've had for the thick low one I've had for 30 years, and it sat in a shed and got a bit rusty.
Okay.
And then I painted it with anti-rust, anti-rust paint, and then I used a couple of spray cans of radiator paint.
Okay.
It's why buy a new radiator when you've got one already?
Sure. Yeah. Thanks.
Going
back to my cooking now. Bye bye.
But the point about them is if they were running at 80, if normal radiator runs at 80 degrees C, the boiler, the heat coming off your gas or oil-fired boiler produces water into your radiators about 80 degrees centigrade. This, I'm only getting 40 to 45 to 50 degrees centigrade from heat pump, and match at the moment it's set at 45. And that is only going to produce half the heat. You can divide, the temperature of the radiator drops by half, the heat it produces drops by half. It's as simple as that. Therefore, you have to double the size of, or the number of the radiators you've got.
Okay, there's a question here about how many air changes is the system designed for. I'm not quite sure what that means.
Well, that's a very interesting question.
Rob.
That's me.
Oh, hello, Rob. Yes, Rob, I know very well. The answer is, if you've got if it's properly working as a passive house, I think, I don't have this at my fingertips. I think a passive house works at about 0.3 air changes an hour.
Is there a legal requirement, a minimum standard?
The building inspectors know that I'm making this of a passive house. I'm trying to make this a passive house standard, and they haven't queried it. And certainly on the passive house courses I have attended, that has never been challenged. The point is that a normal building has about 6 air changes an hour. And that, if you do your calculate, put 4.2 QV delta T, if you remember your building physics, it means that requires an awful lot of heat to compensate for that heat loss, ventilation. And one of the points about passive houses is they are really well sealed, built very tightly, but then they're ventilated with a heat recovery system. And the point is, if you're ventilating, well, let's say if you're ventilating 2 air changes now and your heat recovery is giving you back 80% of the heat you're taking out of the building, then that's 1 kilowatt in, if my maths is correct, 1 kilowatt in 5 you're getting back. Sorry, 5 kilowatts in 1, sorry. 5 kilowatts, so you're getting a lot of your heat back through your ventilation system. So it's the reason for the MVHR is that it allows you to have a relatively low net ventilation rate.
So that 0.3 an hour is regarded as adequate for health reasons, presumably, if that's an allowed.
Well, that's the effective ventilation rate. When the MVHR is working, you're getting 4 or 5 times that amount.
Because of the recycling of the air.
Yes, because you're recycling the heat.
So what does that amount to? That comes up to about the 6 air changes, is it? That
No, it doesn't get you to 6 air changes. I think you're getting down to about 3 air changes.
3 air changes. Okay, yes. Thanks very much.
And I think you could clarify one thing, Ian. I mean, I once tried to do some calculations for our kitchen on the air changes per hour. And basically, once I've taken the heat capacity of the volume of the air times 6 every hour going out the window and working out what temperature it is, that's actually a lot of heat, as you say. But then I think I heard that actually those air change rates are at a particular pressure difference rather than what would normally happen on a calm day. So am I right in that these figures are at a particular pressure difference?
Of course, they're at a particular pressure difference. Is if you've got a fan which is trying to extract air out of onto a western wall, say for example, and you've got a strong westerly wind, then your fan is going to be struggling, isn't it? So I don't. That's the sort of thing I don't know. I don't understand the theory, and I haven't looked at the theory very closely, and I ought to. Yes, it is something that it would be really interesting to look at. And Rob's point about what is the healthy air change rate, and that's all in the books. One of the passive house books does I think discuss this in certain amount of detail. Yeah. I don't have that at my fingertips.
Yeah. Thanks.
Okay, and Nicole, you have a question about battery storage.
Yes.
Are you there, Nicole? Oh, perhaps she's gone.
Hi, yes, I wanted to ask, because you were saying on one of the other buildings, the solar at the moment is only providing half of the needs for the office. So do you plan to add battery storage at some stage so you can balance that out?
That's interesting. I would have to do the calculations to find out whether battery storage would help there. The issue there is that an office is quite a high energy consumer, because even in the summer, there's a lot of lighting and there are a lot of computers. And then in winter, of course, that's doubled up, because then you've got the heating, even there that's being supplied by a ground source heat pump. It's just, I know from observation, from looking at the just plotting the data from the electricity meter and plotting the data which I'm getting from the solar panels, that the amount of energy the solar panels producing is only half of the consumption of the annual consumption of the office. So my plan was to put more insulation in the roof of the office, because I think part of the problem is the roof of the office is insulated with mineral wool, and either I should use something which is more efficient, or, well, yeah, something which is more efficient, but how to do it is the question. Do I replace the mineral wool with something else, or add something to the mineral wool to make it more efficient? I have a feeling the heat losses are going through the roof. All the lighting is LED lighting. I can't do a lot about the computer consumption. Batteries, the trouble is the most consumption in an office is during the day, and which is when you've got the sunlight. I'm not sure the batteries are going to help very much for the office. I haven't done the calculation, and the calculation would be useful to do, but I don't know the answer. For a house, of course, where most of the consumption might be in the evening, then batteries can be very useful, yes. At the moment, I'm not considering batteries because batteries still are quite expensive, aren't they?
One thought about the computers and stuff. One thing we've found that makes an enormous difference is turning things off. And I don't know sort of how many people and computers you've got there and how diligent they are about turning things off, but the sort of level of sort of zombie power demand for things that either are on standby and not, you know, with not a very efficient standby, or just left on when somebody's gone to get a coffee or gone off for lunch, can be really quite marked.
Well, there's obviously there's a server which I know from observing generates a lot of heat, but that runs the whole time.
Yeah, I believe there's some sort of modern servers turn themselves off when they're not, or rather they turn themselves down when they're not actually doing things, which helps. But I thought the one bit of experience I'd be interested to hear your thoughts on, Ian, which is you've got both a ground source heat pump and an air source heat pump, and that's sort of quite unusual.
Yes.
So I wonder, you know, what your thoughts are about the relative merits of the two.
The ground source heat pump should be vastly more efficient, and the ground source heat pump has been a really good news as far as the office is concerned. It's given them a very reliable heating system. It goes into a tiled floor, and it provides very comfortable space. It's been absolutely wonderful. The air source heat pump so far has been a little problem. Well, it's only been running. It has hardly been running at all. It was really commissioned a month or so ago, and the heating engineer came back to he had some new energy curves given to them by Wiesmann, who make the heat pump, and he wanted to reset some of the controls. And frankly, it's not working totally properly yet. It should do. I don't see why it shouldn't. It produces enough hot water. It's just that it's not feeding through to the heating system. There's something funny about the way it's set up. That will get solved.
Yeah. For those of you who want to explore your home or your friends' homes or your relatives' homes, Cambridge Carbon Footprint has a couple of thermal imaging cameras which you can get trained in how to use. It's very simple, and then you can borrow a camera to take away and use. And because of COVID, the training is no longer in person. It's online, and there's some really neat little, there's a little session, and there's four of these sessions happening over the winter, because it's much best time to use it is in the winter. And then there's various little videos which help you, show you how to actually use the controls over the camera in case you've forgotten by the time you come to use it. There's a neat system being developed with a sort of deposit box, which is actually now screwed to the outside of our house here in Newnham, in which you can collect the camera and then deposit it, and you clean it down when you use it, and there's a day or two quarantine period before the next person borrows it. So we think this is all a really pretty secure way, COVID secure way of letting people have the benefit of the cameras. And it's quite remarkable what you see. We discovered that our builders who claimed that they'd put the loft insulation in the floor actually hadn't. And you can see really interesting stuff when you go around your neighborhood or around your house. And very helpful for identifying drafts coming under the door or around the edges of the windows or things like that. So I thoroughly recommend those. Now, how do I get next one? And then there are just 3 more online tours still available. So do go and have a look at the openecohomes.org website. and see if you want to check in on any of those. And I think that's probably it. Oh yes, and then if you could write in the feedback how this session was for you. What did you particularly enjoy? What did you not enjoy? Or whoops, what's going on here? Or not enjoy? And if for some of you it was too technical, some maybe it was not technical enough. Do say, because that all helps us get the balance of things, you know, of the Open Eco Homes right. This is a charity. Cambridge Carbon Footprint is of course a charity, and Open Eco Homes is a project of Cambridge Carbon Footprint. So online donations really help us do more of these. So if you would like to make a donation, please do go to cambridgecarbonfootprint.org/donate. Maybe Libby, if you could put that in the chat. And we also have a link for a survey. And do you have the link for that, Libby? Can you put that in?
I've put in the donate one. Yes.
Have you got the survey link, or should I put that in?
I haven't got the survey link.
Okay, I'll put that in. Thank you very much for coming. Let me just stop sharing that. And so I've just shared with you the link for the survey. And if there are any further questions or things you want to discuss, we can stay and chat a little bit longer with Ian maybe. Otherwise, thank you very much.
Ian,
Very good.
Hello. Hello,
may I
Nicole.
ask, I mean, you've treated it as an experimental sort of project, and you know, lots of learnings on the way. So can you list, say, your 3 big learnings so far? That'll be really helpful.
I think the biggest was that when the roofer who put in the roof lights and put the extra insulation in the roof did it, I thought it'd be very easy to just draft proof the openings and plaster them or finish them off, and I thought that'd be easy. What I hadn't realized that I really should have controlled the way the roofer worked. And when he was cutting into it's pretty obvious really, when he was cutting into the vapor barriers, which were already there, he wasn't careful enough. And therefore I'm chasing around for edges, which I can draft proof to. I think that was the first learning point, was that there's a very good course you can go on with Velux if you want to, if it's really the roof windows you want to put on. Velux do a course on how to install Velux roof windows. They're very good at how you fold back and make the junctions of the sarking felt, the sarking membrane, what normally is a breather membrane, which is on the outside of the insulation under the tiles, under the slates. They're very good at that. They don't really cover in their discussion how you do the same thing and tape and seal to make it draft proof on the inside. They sort of do, but they don't. They're much more interested in making it waterproof than they are making it draft proof. So if you go on one of the Velux installation courses, they, I think, are very useful. So that was the major fault, and it was entirely my fault. I wasn't careful enough in instructing and supervising the builder in doing what he should do, and he didn't understand the issue. How many builders understand what a vapor barrier is? Quite a few don't. Anyway, so that was the first issue. I think everything else has been pretty straightforward except for COVID. It's just that I had someone who was working with me who's a really good pair of hands, very strong, very good at being told what to do, did it, and we worked together and got a lot, achieved a lot. And then COVID came along, and I felt I just couldn't work with him, because you just can't work closely with someone who's not in your bubble. He was a student, and that kind of knocked me back quite a lot. I don't think there's anything else that has been particularly difficult apart from that. And COVID has, taken 3 or 4 months off the project, just because finding people to do things. I found a very good joiner who has been produced, who's made the stairs, which you saw, and has done a few other things. And he's a first-class joiner, and he's coming back on Monday to fit the kitchen. Finding good craftsmen, I suppose, is an issue, and really good craftsmen are difficult to find. Trouble is, I'm picky.
You think it's more difficult?
As an architect, I've done about 50 projects over my career. And I would say in that time, I've worked with 30, 40 builders. I'd say about 5 of them I'd class as really good. The rest were average. And I really, as an architect, I really enjoy working with really good builders, and they are privileged to work with. They're enormous fun, and you learn a lot from them, and they can do wonders. But there aren't very many of them around.
So can we ask you to share your top list, or do you want to keep them for yourself?
What? The top list? The builders? No, it's
Yes,
well,
please.
no, the top list, the best builder I worked with has gone bust, unfortunately. He was they're a firm called Blythes, who were based in Norfolk. They did 2 projects with me, both of which won architectural awards and environmental awards, and one of them a Civic Trust Award. He was a first-class builder. There's another builder who came, I think they're based in Norwich. I did a school project with them. They were very good. And then there's a very small builder who's on the Blackwater in Essex, and I did some farmhouse work there. He was a first-class builder. He had very good job. He had most wonderful carpenter or joiner. He was absolutely brilliant. It's yes. What else can I say?
Do you think it's made it more, the COVID situation is making it more difficult or less difficult to find good people and people who've got the availability?
I don't know about that. And the joiner who I'm using to do some of the finishing off, I just have to keep my distance from him, because I can't really work in the same space as him because of COVID. It just, so I'm just going to have to set him off doing things and approach at a distance with a mask on.
Yes.
And make sure the space is well ventilated. And I'm just very nervous. I mean, I'm over 70, and I'm very nervous about getting this illness, and I just don't want to get it. It'd be very unfortunate if I did.
And I mean, but even if ultimately we end up getting it, let's make sure they've got lots of treatments and all the rest of it.
Well, I'm putting my hope on a vaccine.
Yeah.
Yes.
Well, are there any other comments or questions for
No more comments, I think.
Yeah.
So it's been a really interesting
Yeah.
talk, I think. Yeah, fascinating.
Really interesting. I think one of the things it also demonstrates, I'm really pleased about, Ian, is that it's small, and some of the eco homes that people build, they're actually enormous, and it may be that the energy use per square foot is actually quite small, but if the house is enormous, it's still using a whole load of energy. And this is a really compact, beautifully insulated, thoughtfully designed, lots of reclaimed materials. And so I think it really does deserve the title you gave it of a carbon neutral studio flat.
When it's finished, when the PV is on the roof and all that is working, it should be. Hope it will be carbon neutral. Be nice if it were.
Yeah,
and I think Nicole is right that batteries will help because they will take some of the energy from the day and allow it to be used at night. Yeah, batteries are a good idea.
Yeah. Certainly, I think, and they are coming down in price, but certainly we're thinking of putting a quite small amount of PV on our house, but it's all we've got space for. But we're very much thinking about putting on an inverter that will give us the capacity to put in batteries either immediately or in a year or two. Just basically making provision for that, because I think that's definitely the future, or equally it's here. It just depends on how much you need it to pay its way. So,
do the batteries take up much space?
Yes, they do. But I have space on the ground floor of this building where we could put batteries.
Are they like car batteries or?
They're bigger than that, I think.
Well, I mean, they vary. I mean, the cheapest ones are sort of like a rack of car batteries, but then you also get ones which basically look like the sort of hi-fi you would have had in the 70s or 70s or 80s sort of thing. I mean, they're sometimes described as fitting into a 19-inch rack. So they're sort of modules about like that, and you could have one which wouldn't store you a lot, or 4 or 5 or however many.
There is a firm that I can't remember what they're called now, Bramble, who you can buy your solar panels from, and if you're prepared to do your own wiring, they will also sell you the batteries. A friend of ours in Scotland has done it, and he's got I think 3 or 4 panels, and below the panels he has a rack of 3 or 4 batteries, and that feeds into a house. It feeds into a holiday home which has no mains connection at all, so they're entirely lighting the building from the panels and the batteries. I mean, nowadays you can buy them from this firm. I can't remember what they're called. I need to research that. I remind myself what that is.
I mean, they're becoming increasingly common, I think, now. And so Midsummer Energy in Cambridge supply both the batteries and the inverters and the panels and the things like that. Either as you can build your own system if you can wire them up, or there's the sort of thing that would be supplying to an installer who would then add them together and build your system.
Okay.
And of course, in Cambridge, we're more likely to be wanting to connect to the grid rather than be completely off grid. But it's a very interesting space. It definitely makes, and you can also buy and sell electricity. So one of the things we're interested in is putting in the battery. So our small amount of PV, which is only going to be a couple of kilowatts. I mean, we can fit on either 4 or 6 panels, and then so that feeds into the battery, and that will then let us cook on electric in the evening when the sun's not shining. Yes. But it would also allow us to buy low carbon power at 2 o'clock in the morning when, for example, the wind turbines are all humming away without any power.
And put it into your batteries,
Put it in the batteries and then use it ourselves at times when we'd be having to buy higher carbon power. You've nearly got automated software to let you do that automatically. I know 1 or 2 people who are every 4 o'clock on every afternoon, they go and buy and decide whether to buy or sell power, which is, I mean, personally, like,
no, I think we don't want to do that. We want to have this thing happen automatically. Yeah. So some people are using their cars as their batteries, as their battery, which seems a bright idea.
It's all coming, and there's 1 or 2 startup companies that are starting to do that for you automatically, I think. And some of them, they will provide the battery, but then they charge a margin on the power they sell it. Or so it's a very exciting space. Definitely worth being prepared for. Batteries. We think we might put in a small battery to start with and make sure we've got space under our stairs to put more batteries when they get cheaper and the systems get more automated for trading power on this sort of demand management, because it's so much cheaper not to have to generate power than to, if you can use surplus power comes to low carbon stage. It's going to be a really important part of making the power grid work and decarbonise. So sorry, I've rattled on a bit there. Any final comments from anybody? Or we should maybe all go off and enjoy the rest of our evening.
Thank you.
And I hope, Claire, your cooking's not overcooked.
Well, thank you, Anne and Libby, for co-hosting it, or co-chairing it. Very useful. Thank you very much.
Lovely to see you.
All the best.
It's finished.
Bye.
Thank you.
Thank you, Ian. Good night.
Bye-bye.